Hi guys, Mrs. Delise in here. Welcome to another lesson of Algebra 2. Today we're going to be learning how to determine the end behavior of a polynomial function if it's in factored form. If you are doing if you're getting this degree and the leading coefficient of a polynomial in standard form, it's very easy. If you watch the previous video about polynomials 1.1, all you have to do is look for the largest exponent. But what if it's not in standard form? What if it's in factored form? For example, example number 1, given the polynomial function f of x equals 5 times x plus 1, x minus 4, x minus 2, the long way to get the degree and the leading coefficient is to multiply all the factors together. And that will take a lot of time because you would have to multiply x, distribute x plus 1 to the x minus 4, and then distribute to x minus 2, and then multiply everything by 5. And that is so much, too much to do. So, in order for us to take a shortcut on getting the degree and the leading coefficient, this is what we're going to do. Let's have an example here. Given each polynomial function, state the degree, the leading coefficient, the y-intercept, and let's add something, the x-intercept also. Okay, let's start. Because this is in factored form, we need to extract all the x term, right? So if I'm extracting the x term, because that's where I'm going to get my leading coefficient and my degree. So I'm going to extract those. That is x times x times x. X times x times x is 1x cubed, right? Because everything has a 1x, 1x, and 1x. And so 1 times 1 times 1 is just 1x cubed. Now, Miss, do I really have to put the 1? Technically, you do not have to put the 1, but I have a purpose in putting that. So just hold on a minute there. I have my degree, that is a 3. So my degree is 3, and 3 is an odd number. And because I have a degree that is an odd number, I know that this graph would be on an opposite direction. And that's what I meant by OPP, opposite direction. For my leading coefficient is this one right here, which is in this case, it's a positive 1, right? Positive 1. And because my leading coefficient is a positive number, that means on the right side of my graph, it's going to be up. And so on the right side is going to be up. And because the degree is odd, meaning they have to be on opposite direction, the left side here is done. Done. I got my degree and I got my leading coefficient. Okay, moving on with the x-intercept, which we are very familiar. Let's change the color into purple. We have x minus 2 equals 0. That is, x is equal to 2, and we know how to do that, right? X plus 5 equal to 0. We'll get a negative 5. And lastly, we have x plus 3 equal to 0. I'll get a negative 3. And all we have to do is write them in order. I have a negative 5 comma 0, and then I have a negative 3 comma 0, and then I have 2 comma 0. And for my y-intercept, I think we are so familiar with this. I know that for my y-intercept, I always have an x equals 0. So I know it's going to be 0 comma, wait, I do not know what the y is yet. Oh, to get that, I'll plug in a 0. 0 minus 2 is a negative 2. I'm just plugging in here, okay, you guys? 0 minus 2 is negative 2, followed by 0 plus 5 is 5. 0 plus 3 is 3. Altogether, that is negative 30. And so, I am missing a negative 30 in the y-intercept. Okay, that's it. I got my degree, my leading coefficient, x-intercepts, and my y-intercept. For B, let's do the same thing. I'm going to extract the x term. So I have 5x, I have a 3x, and then I have a negative 2x. And let us multiply them together. In red, I have 5x times 3x times negative 2x times negative 2x. Oh, do you guys notice why I have 2 of the negative 2x? The reason for that is because this term is being squared. That means I have 2 of these. That's why I'm writing 2 of them. Okay, let's multiply the number first. We have 5 times 3 times negative 2 times another negative 2. And that altogether would be positive 60. X to the power of, we have 1, 2, 3, and 4. That is x to the power of 4. So our degree is the exponent, which is a 4. And 4 is an even number. And because it's even, they go on the same direction. Either they both are up or they both are going down. And that depends on our leading coefficient. And our leading coefficient is positive 60, right? Because we multiplied all the coefficients and we got a positive 60. So positive 60, and because it's a positive, on the right side, it's up. So on the right side, it's up, but they have to go on the same direction. So on the left, it's also up. Does that make sense? Let's make that shorter. Okay, moving on to our x-intercept. We have 5x. Of course, 5x is equal to 0. That's divided by 5. That's still a 0. So I know that one of my x's is 0, 0. And then I will have, what do I have? 3x minus 2 equals 0. That's 3x equals 2. You add 2 on both sides. You have x equals 2/3. That is followed by 2/3, 0. And lastly, I have a negative. We have so little space. Negative 2x plus 7 equals 0. Negative 2x equals negative 7 because you're subtracting 7 on both sides. And then you're dividing a negative 2, so they end up both positive negative 2. So it'll turn into a positive 7 over 2. Or you can put 3 and 1/2. That is super fine. And then for the y-intercept, I am going to, I want you guys to concentrate on this one. You know, for the y-intercept, I'm plugging 0 in here, plugging 0 in here, plugging in 0 in here, right? I will plug in 0. That's why our y-intercept is 0, comma, we still don't know. So if I plug in 0, if f of 0, 5 times x, so 5 times 0 is 0. If this is 0, does that mean I multiply everything by 0? Is everything multiplied 0 just 0? So I don't have to waste my time plugging in 0 in each of those if I know it's going to be 0 anyway. Does that make sense, you guys? Okay? Even if you continue plugging in 0 here, it will be 0 because you're multiplying all of them by 0. Okay, let's have another example. Negative 5. Why don't we put this on the top? So I have a negative 5. I have x and x. Why I'm doing x and x? Because of the x squared. So it's written twice. So I can just write x squared, but I prefer write x and x so you can see. And then I have negative 5. Ooh, remember, I put that in pink because that's our leading coefficient. Negative 5x to the power of 3. And 3 is an odd number. An odd number goes on opposite direction. And of course, really, really easy. My leading coefficient is negative 5. Negative, because it's a negative, on the right side is going to be down. So on the right side, it's down, and they need to be opposite, so the left side is up. Okay? That makes sense? Moving on, we have x-intercept, which is, I think by now you guys are familiar with how to do it already. So should I still write that down? X minus 1. Hopefully we don't have to write this all over and over again. And x equals negative 2. Oops, that doesn't look like negative 2, right? So you have to write the smaller number first, yeah? Negative 2 comma 0, and then 1 comma 0. And then for the y-intercept, we talked about that over and over. It has just plug in 0, so that is negative 5. 0 minus 1 is a negative 1. But negative 1 squared, I'm plugging in 0 in here, you guys, okay? Negative 1 squared is a positive 1. 0 plus 2 is a 2. So this is a negative 10. Okay, you guys agree? That's 0 comma negative 10. Okay. Do you guys think you need more examples? All right, let's have more examples. We have x squared, or you can write that as x and x because I have two of them. This is being squared. This one is also 2. And then usually what I do is I just write x and x, right? You can do that too. And then I have an x, and then I have, why am I writing it twice again? Because it's being squared. And altogether, negative 2. So I have 1 times negative 2 times negative 2. That is a positive 4x to the power of 2, 3, 4, 5. So 5 is an odd number. And every time your degree is odd, your graph go on opposite direction with a leading coefficient positive. That means it's right up. So in the right, it's up, but they have to be opposite, so the left is down. Okay? With my x-intercept, can I make a shortcut here now? For my x-intercept, I have negative 1, oops, wrong color, negative 1 comma 0. That makes sense? And then 3 over 2 comma 0. And then lastly, I have 4 comma 0. I got the 3 over 2 from making this equal to 0. And I'm hoping that you guys already know that. Oops, 0. 2x equals negative 3 is equal to 3 over 2. Okay? For my y-intercept, what do? We plug in 0, f of 0. 0 plus 1 is 1. 1 squared is 1. 0 minus 4 is negative 4. Negative 2 times 0 is 0. 0 plus 3 is 3. 3 squared is 9. So altogether, it's negative 36. Okay. For more examples. So I think we can do 3 and 4, and then I think you can do the rest for practice, right? Let's do 3 and 4. I have, my degree is x times x times x, so x cubed, 1x cubed. So 3 is odd, goes opposite. My leading coefficient is positive 1. That means it's right up. So let's put that in there. On the right, it's up, but they have to go opposite. So my left is down. And then x-intercept. Oh, this one is really easy, right? I don't think we even have to make that equal to 0. Negative. Oh, no. It messed up our color. You have to redo that because the tendency is you are going to get confused. Right up, left. And then our x-intercept would be -4, 0 in order from smallest to the greatest. And then for the y-intercept, what do we do? 0, 0 plus 3 is 3, 0 minus 2 is -2, 0 plus 4 is 4. So this is negative 24. 8 times 3, yeah, negative 24. Okay, yay, last example. You have red color, you have -3, we don't have a space. We have -3, and then we have x squared, we have x. So this is -3x to the power of, oops, 3. Okay? -3 to the power of 3. 3 is odd and opposite. It's always odd and opposite, right? Okay, and then for the leading coefficient, we have -3. Oops, almost. For the leading coefficient, we have -3, so that's right. It's going down on the right because it's a negative. So going down on the right, that means it's going up on the left because they have to be opposite. And then for the x-intercept, we have -5, 0 and 2, 0. For our y-intercept in blue color, we have 0, f of 0, -3. 0 minus 2 is -2. But then you're squaring it, -2 times -2, that's a 4. 0 plus 5 is a 5. So this is 20 times -3, -60. There you go. There you have it, you guys. Hopefully this video will make it easier for you to identify the end behavior of a polynomial function, even if it's in factored form. Okay? I hope that you learned something today, and I will see you on the next video. Thank you for watching.